Hello again, you sick, twisted weather freaks. Welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from weatherrisk.com, your commander of chaos, your captain of confusion, your colonel of catastrophe. Let's talk about this week in weather. And if you are in the eastern third of the country, eastern half of the country, we are in winter weather lovers hell because we are stuck in a pattern which shows absolutely no signs of breaking for the next 2 weeks, what I can tell. So let's get right to it and see what's going on here. Now, this first image slide here we'll talk about, this is from last week. Notice the upper right corner there, January 4th, we had a big upper low in Iowa, Minnesota, a lot of warm temperatures on the East Coast into New England, and then another big monster trough coming in Eastern Pacific. So you can see this is the Pacific pattern, just boom, boom, boom. The fire hose bringing in on those 180, 200 knot jet streaks across the Pacific, all the way from eastern China right to almost the west coast of California. Big bombs coming through here, and of course these are the systems causing all the flooding and the huge snowfall. I've posted some of this on the Facebook weather risk page. You can see it there, and just getting blasted here. The drought conditions in California, the reservoir is rapidly being refilled as more systems coming up here. No signs of this change in the next 10 days that I can see, and probably the next 2 weeks. That was January 4th. And then, of course, they got hit a couple of days ago. That system here off the California coast, in the Eastern Pacific, that's the one that caused a lot of damage. And then, of course, this is it moving in. This is January 10th. The system crashing into California. Big storm hit those guys a couple of days ago. Another weak system moving through the eastern U.S. And the point here is, you see the blue arrow? There's your Arctic jet stream. So this is coming in from Alaska across northern Canada and dropping down into Quebec. That's no way to get cold air into the eastern U.S. or the central U.S. This just doesn't happen. The red line shows the Pacific jet stream just plowing right across the country from west to east, bringing in the moisture, the systems rapidly moving across the country and just battering all the west coast from Vancouver down to California and San Diego. Depending on each storm track is a little different. Temperatures last I guess his last 7 days. Look at this. Well, there's no cold air to speak of at all. And of course, now remember, obviously, that the further north you are, the warmer the temperature anomalies become. Because typically, in Saskatchewan, Manitoba, Montana, Minnesota, North Dakota, it's very cold in mid-January. And as you can see, the anomalies, given what they're saying, are running anywhere from +7 to +20 degrees above normal, depending on where you are. So very mild pattern. Rainfall, precipitation the last 7 days. You can see the California coast just getting battered here. Look at those numbers, those values. That brown stuff, that's 10, 12, 14 inches of liquid precipitation. Excuse me, over the past 7 days, really getting hit. Notice that the plains in the Midwest, not that much precipitation. Some activity in the southern states into lower mid-Atlantic, but not a lot. Clearly, all of this is a western U.S. weather pattern here, as they, this is how they get out of their drought situations. If you go back and take a look at these news stories from last year, it's going to be 10 years before they get out of the drought. Droughts are now permanent condition. Well, the atmospheric rivers just, these are events which occur, which are not common, which occur at the end of the bell curve in terms of the probability distributions. They're extreme events, and like all extreme events, they don't obey normal laws. So when people say, it's going to take 7 years or 10 years for it to come out of the drought, that's nonsense. Because when you're dealing with extreme events, strange things happen. And as a result, you can't use the same standard, the same guide. So that's why all those predictions were nonsense. All right. Now this here is the current map. Let's take a look at the current map here. There's our low pressure area in the Mississippi Delta, Arkansas, southern Missouri. Now, if we had the right upper air patterns in the northern portion of this map, this would be an East Coast snowstorm, but it's not. You can see that, again, there's a positive anomaly north of the Great Lakes, but there's no way to get the cold air into the country. So we're just getting Pacific air coming in. Notice there's no mechanism to deliver the cold air in northern Canada into the Great Lakes or New England. So this is just a rainstorm. A very nice one as well. There's another major trough in the eastern Pacific coming in no doubt about that, for the weekend to hit the West Coast again. Here's the latest surface map. There's the low pressure area, fairly well organized, fairly strong in western Tennessee, and then in southern Indiana. South of the front, Georgia, Mississippi, Alabama, Tennessee, the Carolinas is quite warm. There's a lot of severe weather outbreaks there. We have numerous severe thunderstorms and tornado watches. Severe thunderstorms this afternoon here, watch in eastern Kentucky, then tornado watches in southern Alabama, in northern Georgia, and southeastern Tennessee, and then northern Alabama. So very active in the severe weather, and this is this is unusual to see in January. Not unheard of, but it is unusual, and it is indicative of the mild pattern we are in. Here's the radar. As of, I guess, 1 o'clock this afternoon, you can see all the activity there moving through with this next system. Now, what happens is this trough here over Arkansas, Mississippi, that really amplifies and goes boom when it reaches the East Coast. And again, if we had a upper air pattern supportive of this, this would have been a very impressive East Coast winter snowstorm. But then again, if my grandmother had balls, she'd be my grandfather. So, you have to deal with what's going on here. And the other thing is, of course, look at the West Coast. You see the next energy coming in here, and this keeps these systems moving progressive. These systems can't stall. You can see the trough coming in here. We start from this pattern to this, and now to this. You see the system's slamming into the west coast of North America. And that forces this next trough, even though it amplifies very quickly, to move steadily off the east coast. And you can see when this sort of flow pattern, again, look at the blue arrow. There's no path or mechanism in the northern jet stream to bring the cold air southward. There just isn't any. And that's a real problem. Now, a few days ago, some of my weather friends and hobbyists, weather weenies, were looking at this and going, well, look, we get a second low that develops off the coast, and maybe this could bring precipitation and cold enough behind the low. We might get some snow out of it. There were some of the models were hinting at this. This is nonsense because you have to look at the atmospheric structure of the system. So when you get a low that's going to track up the coast like this, in this sort of structure, let me call up a good map here. You can see here. Okay, the moisture is moving north, and you can see here on the radar. Now, as this moisture moves north, what happens is after the cold front gets through, you get in a dry slot. And by dry slot, let me show you what I'm talking about here. Bring this front. Here, in this area, this is all dry slot. So the main low comes up this way, and here brings the main low up. The precipitation goes through Virginia, North Carolina with the cold front, and then this is all dry slot. So as a result, even though the low looks like it's doing something here, it's all dry slotted. And you can see that and look what I'm talking about. So this here is now Thursday night into Friday. You can see the dark green, the heavy rain, and the brown is the dry air, right? There's the low in western Pennsylvania. Now the second low moves off the coast, but we are covered by dry air. So all the moisture with this coastal low is off the coast. New York is dry, Pennsylvania, New England, Virginia, Maryland, North Carolina, West Virginia, all dry. Whether you can see that, so that's why there's nothing. That's why this doesn't do anything, because we're just in the dry sinking air behind the first low. So, but now the time it gets started, it's way out to sea. There it is. There's the low. But again, you can see the moisture problems here. There's the low develops off the coast, and the moisture is off the coast as well. And there you go, it's out to sea. High pressure coming down, bringing the cold north winds. Finally, a little bit of cold air here. You can look at the lines here. You can see them bringing the cold air down from Quebec, Canada. Finally getting a little cold air in across the east coast and the Ohio Valley, but that's also dry air. So as a result, when the second coastal low tries to form, it takes forever to do so, and it's well off the coast, and it's out to sea, and there's no precipitation. Then behind it, this next system coming in here, on January 15th, that races eastward, and that becomes a system for the plains, the Midwest, moves up to the Great Lakes, pulls up mild air, so we turn mild again early next week, and the front eventually moves through the low goes up to the Great Lakes, and then the front falls apart. It doesn't bring a lot of rain to the East Coast, mainly through the Ohio Valley and the Great Lakes. And then here is January 17th and the GFS and the European for January 17th. And there is, some differences with this system here. But generally what happens is you can see the GFS has one trough on the west coast and another one coming down from Gulf of Alaska. The European is a little faster with this. The trough is now in Texas and Oklahoma, and the trough coming down from Alaska is now in British Columbia. But in both cases, there's a big ridge here, a very strong mild pattern. The European is warmer than the GFS because the ridge on the on the GFS in the upper left is more in eastern Canada. But both models have a pretty big ridge here, so the temperatures really warm up again next week. And when these systems come out, you can see what happens. This system for January 17th, and then in 18th and 19th, you can see how it moves. There's the trough on California on the upper left, January 17th and 18th. And then on January 19th and 20th, it's in Texas and Oklahoma. So the ridge really begins to build here, like I said, on the East Coast, on the Great Lakes, the Midwest, and it turns warm. Look at this. Here's the next system. This is January 18th in the upper left, 19th, and then 19th, 20th in the bottom right. So another big low coming out of the Delta into the Midwest with Great Lakes. Get some snow in Iowa and Nebraska, southern Minnesota, Wisconsin, northern Michigan, but everybody else is rain and warm up and down the East Coast and the Ohio Valley. Now, the European has a little high here in northern Quebec and wants to have a little bit of winter precipitation with this before it changes over. Now, this is a week from tomorrow, January 20th. You can see the mountains of New York State, Vermont, New Hampshire, Maine get snow out of this, a little bit of ice beforehand, but it goes over quickly to rain, no doubt about that, as the low lifts up into Quebec, Canada, Montreal. So that's the next week. There's nothing going on here. You know, these systems just boom, 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 moving right through the West Coast and, moving through the Rockies and the Plains, the Midwest, and the Great Lakes. All right, let's talk about our teleconnections. Let's see what's going to happen in week 2 and week 3 if we can. So one way we're going to do this is by taking a look at our teleconnections, which is, weekly, subseasonal, what we call week to week general overall patterns. So in the jet stream, so there are 4 teleconnections here that we dominate the weather pattern in North America. The red line shows the 2 Atlantic teleconnections, and on the right hand side, and then on the left hand side in the western portions of North America, we have 2 teleconnections on the Pacific side. So on the Atlantic side, we have the Arctic Oscillation, the AO, and the NAO, the North American Oscillation, also known as the Greenland Block. And then on the Pacific side, or the left-hand side of the red line, we have the EPO, the Eastern Pacific Oscillation, or the Alaskan Ridge or Low, and then we have the PNA, which represents either the West Coast Ridge or West Coast Trough. So that's what we're looking at here, and there are several combinations. So, for example, on the Atlantic side, we have the Arctic Oscillation, the NAO, and you can see there's all different possible combinations here. Positive, 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 neutral, neutral, negative, negative, all different types. And then same thing on the Pacific side. Again, the PNA on the West Coast, the EPOs, the Alaskan Ridge, all different possible combinations here as well. So just wanted to point that out to you. Now, if we look at our graphs and charts and see what's going on here with these various models, let me cut this out and we can bring it. There we go. So here we go. So this here is the Arctic Oscillation here. And you can see right now we're slightly negative. And then most of the models generally keep it negative through January 19th to 20th. And then generally negative right through until the end of January. Not strongly negative, but sort of negative. The NAO is neutral. And you can see here right through, it says neutral right through the period. Okay, well there's our NAO, that's fine. And now let's take a look at let's take a look at the Pacific side now. Here's the EPO on the top. The EPO is neutral. You look at the black dots. Now it has a spike to positive, which means Alaskan low coming in. But then towards the end of the month, it drops to sharply negative on most of the models. And then the PNA is also staying generally neutral to slightly negative as we go through January. So the only thing here which looks really decent is that we have a negative Arctic Oscillation late in the month and an EPO, which means a big ridge stretching into Siberia and Alaska, which could bring a more cold air in late. Okay, so it's not very, very good pattern. If we look at our MJO features here, we can see we have 3 different models we can look at. The European, oops, let me bring this forward. Here's the European, the GFS extended, and then the CFS. And notice they all take the MJO currently either neutral or right on the neutral phase 8, and then goes right through here into phase 1 and phase 2 and phase 3. Now, if you remember last week, many of the models had it in phase 8, but out here in the middle of the phase 8, that didn't happen. The MGO did not move into phase 8 at all. And phase 8 is what we were hoping for, to get a colder and stormy pattern. That did not happen. And because that did not happen, that's why, let me call it up here, which map is, that's why this system became a rainstorm. Remember this one last week, there was some talk that it might be a winter storm because the MGO was going to phase 8. As we can see, phase 8 did not happen. It didn't make it into phase 8. It was neutral. You can clearly see that. All these have a neutral circle, neutral circle, neutral circle. Okay, so then what they take it into phase 1 and phase 2 and phase 3 right through the end of the month, almost in February. All right, well, what does phase 1 and 2 and 3 mean, especially phase 2 and 3 in mid and late January? What does that mean? Well, generally, again, this was phase 8 and 1, and if it had gone to phase 8 and 1, it would have produced a snowstorm for the East Coast, but that did not happen. Instead, what we're looking at here is, if you look at phase 2, which is, there you can see it right there on the left-hand side, is the blue represents a negative anomaly in the plains of the Midwest. So more storminess for the Midwest and the plain states, not for the East Coast, not for the Southeast, not for the Ohio Valley, and not for New England. And then phase 3 is actually showing a trough on the West Coast and the kind of neutral conditions over the most of the country. And then if we imply that this goes to phase 4, which it might, you can see that the European here is heading towards phase 4 by the end of January and February. If that happens, then phase 4 is a huge a positive anomaly in eastern Canada, which is, the opposite of what you want for winter weather. If we look at the jet stream configurations themselves, this is phase 2 in January with La Nina. And you can see, look at the strong negative anomaly in the middle of the country, and you have a very strong positive NAO in Greenland, not a negative, positive phase, and a big ridge off the East Coast here. This is the exact opposite of a winter weather pattern. This is terrible. This is more mild, and it's great if you don't like snow. If you like snow and cold in the eastern half of the country, this is a disaster. Slide 26 here. This is, you can see, this is phase 3. Holy crap, this is bad. Look at that huge ridge, big trough on the West Coast, huge ridge in Canada, just a mild pattern, no way of getting any sort of cold air into the central or eastern U.S. in any capacity. If anything, you can make the argument that the polar vortex, the two purple areas, that T's represent troughs and the R's represent ridges. Same thing here. R's represent ridges, T's represent troughs. So here you can make the argument that in phase 3, the polar vortex may actually be over in Siberia, leave the Western Hemisphere completely. That's bad news. No doubt that happens. And if we look at the individual models here, okay, this is January 22nd. We begin to see some hint of a pattern change. Notice we're getting a ridge in the eastern Pacific and the mean trough over the Mississippi Valley and the Midwest here. And then a bit of a positive anomaly in eastern Canada. But the problem here is that this is a much colder pattern if this were to develop. Okay, now I'm not sure this is going to develop because the MJO at phase 3 doesn't kind of favor this. As you can see, it doesn't really favor this sort of thing. There's a little bit of a, I don't know if it favors that. So I'm skeptical if this is going to be true. But let's assume for a second that this is true. Let's assume that the models are going to be correct and the MJO is going to be wrong. Okay. Even if this is the case, the ridge is off the West Coast in the eastern Pacific, which favors the trough in the Midwest of the Plain States. This is a cooler pattern for the East Coast, but it's not a winter pattern. Not at all. Midwest, yes. Plain States, yes. Great Lakes, yes. Not for the East Coast. Okay, so while we're wallowing that agony, this almost takes us to January 24th. Is there any hope for this winter at all, which has so far been non-existent on the East Coast? Well, maybe. Let's take a look at it. All right. Now, this here is the polar vortex as of January 12th. So you can see the purple area, the purple arrow. There it is. There's the vortex here. This is the positive anomaly here. And there's the polar vortex. Super strong, super intense, right over Greenland. So, there you go. And when it is very strong like this, the vortex means it's very hard to get the Pacific jet stream, the block. The vortex is very far to the north, and this warming here is on the other side of the hemisphere. So all you have is a complete open pathway for the Pacific jet to come in, and there's no mechanism again to get in the cold air in. Now, there are charts which are showing something changing. Now, this shows you the northern angular mode. Again, this has to do with the polar vortex and the blocking. And back in December, remember we had the big block which showed up in Greenland and triggered the Arctic outbreak and the blizzard for the Midwest? Look what happened here. This is when you could see it showing up here in January, and this is when you had that. So when you get these orange and pink areas here, I get these orange areas, on this chart that indicates that the pattern, there's a positive anomaly is blocking developing in the northern hemisphere. Now we're beginning to see some hints of it late January showing up here, but it's just hints of it. There's nothing to get that excited about just yet. It's just something to think about. We'll see this another way of looking at it here. This here is the GFS. Now this is from Judah Cohen, and you can see here that this is the GFS ensemble. Again, notice back in December when you had the block showing up here in the blizzard and the Arctic outbreak, you could see it showing up here. All right. And now we're seeing some hint of it again developing late January as we move towards February. Just hints of it. Okay, just to give you a little hope. It's, that's all it is, just a little bit of hope. Some other piece of information. This here is the winds at the polar vortex level. And you can see that the green is forecasting the GFS. They're showing the winds are going to collapse. This also shows up on the European ensemble as well. They show the winds on the polar vortex collapsing. That means that this is going to change because when the winds are very strong, you can see all the isobars here, the height lines rather, not isobars, the height lines, keep the winds very, very strong around the vortex. This is showing the winds are going to break down completely. Really, really collapse was moved in February. And it shows it as well here. And you can see this as also. And the temperatures, well, when the polar vortex is very strong like this, it's very, very cold in the Arctic. You see that? Okay. But if the winds break down and the vortex begins to change, the temperatures shoot up, which is what happens here. Look at the green lines. See how the temperatures explode northward as we go towards February. Well above the mean. This represents stratospheric warming. In other words, the polar vortex splitting into two pieces, which would allow the pattern in North America and the Western Hemisphere to change, possibly significant. Okay, but this is way out there. This is just kind of like speculation, really, just informed speculation. Another chart showing it, here we go. This is a nice chart also. Okay, so let me show you how this works. This here is the color scale. The black represents the color scale. Okay, so this represents really, really cold, and this is really, really warm. All right, so now these are the days of the week. So this is the end of January, December 31, day 364. This is day 12 because we're January 12th. Okay, and then this is January 27th. So the point here is that as we go out in time, what's happening is we're seeing all this red showing up as we go further out in time, which represents significant warming in the high levels of the polar vortex atmosphere. Okay, so you can see that, and this here is further out in time. So this is 120 hours out. This is 10 days, 140 hours out, and this is 14 days out. And you can see again, all the models are showing a lot of warming here developing, starting showing up here as we go late in January, which means the polar vortex could be weakening and splitting up into a couple of pieces, which would cause the pattern to change. Indeed, let's look what this is showing. Here's the GFS at 20 millibars at the top of the polar vortex. It splits into two pieces. There's the vortex, and you can see it's quite a bit weaker than before, and now we have two big positive anomalies here and here. So what happens is this positive anomaly slides into North America, and the whole vortex pattern changes completely. That's what this is indicating kind of here. Indeed, also, this is from Judah Cohen as well. You can see right here, by the end of the forecast period, January 28th, we have a huge warming taking place over the North Pole and northern Canada, which represents a major change in the vortex and sudden stratospheric warming, because we're getting the stratosphere, the top of the atmosphere, to warm dramatically. That's where the name comes from. This would represent a big change in the weather pattern and possibly a shift towards a much colder and perhaps more winter-like February and March. We don't now. The other factor here would be the La Nina. If the La Nina continues to weaken, it does really break down in February, late January, February, that would help us quite a bit. So again, there is some reason to have some hope out there. let's just play it by ear, see what happens. There's no reason to say that February, March are not going to be cold or snowy. Oh, but they could also be mild. There's just a little bit of hope out there. So I don't want to be too optimistic about this, but there is some reason to think that things are going to change in February and March. We'll see. We don't know, just maybe. This is meteorologist DT from Weather Risk. I will see you over on the Twitter page, over on the website, and over on the Facebook page.